So you have a multiplayer game, but you notice a bit of lag between when you try to move the player and when they actually move. Well, how do you fix that? Well, you can't totally fix it, but there are some strategies that we can use to help alleviate some of that lag or compensate for that lag. Today, we're going to look at one solution called client-side prediction and reconciliation, and we're going to use an extension called Netfox. Client-side what? Client-side prediction and reconciliation is just a term we use to describe the algorithm that maintains server authority over player location or state, but still allows for that responsive movement from player input. Generally speaking, we want to give players control or authority over the actions or inputs they make during gameplay, like hitting buttons on a keyboard, moving or clicking the mouse button that may map to some action like casting a spell or looking around the map. If we give the player complete control over their player object and not just the input, well, that opens us up to cheating because they can just tell the server where they want to be on the map or how much health that they want. There are probably a lot of games that are getting away with this right now, and you may never know about it, but eventually, if the game takes off, it'll probably become a problem. We alleviate this by giving the player authority or control only on their inputs, mouse clicks, button presses, that can be mapped to gameplay actions. Okay, but why do we need this fancy algorithm? It takes time for the client action or input to reach the backend server or host in the case of a P2P setup. So what you're doing is your client input actions like moving or casting a spell have to travel all the way to the server, be processed and sent back before that movement or action is processed and applied to your local client. If you've played around with any of my Brackeys tutorial games, this is exactly how they're set up. And the second you probably deployed that game anywhere outside of your computer or local network, maybe you put it in the cloud or your friends hosting the game, you've probably noticed that lag immediately. Client-side prediction and reconciliation is just one way to tackle this problem. Now, I'm not going to go into the inner workings of how this is done. I'll put some resources down below in the description if you're interested in learning more. And if you are serious about multiplayer game development, I definitely recommend checking those out. Generally, this strategy allows your players to move immediately upon key press to have that responsive feedback while still maintaining server authority over the locations and actions of the players. Instead of waiting for our server to finish processing the input data before applying it to our local client, we immediately move our player, client prediction, and then send that data, that input movement data to the server where it is then simulated, and then it creates states of our actual location of where the player should be and sends that back to the client. At that point, our client can reconcile those states from the true authority and make sure that our future movements and states are built on top of or in line with the correct, accurate states of the past locations sent from the server. There are additional strategies to smooth out these corrections or make them less noticeable, but that's a bit out of scope for this video. If you'd like me to cover the inner workings of the strategy, let me know down below. So when do we use this strategy? Well, there's no silver bullet, there's no one size fits all as far as lag compensation. It really depends on the type of game you're developing and also the game's requirements. Specifically, this extension was designed for action role-playing games, think Diablo, but not so much for competitive, extreme high-paced games or first-person shooters. More for slower paced multiplayer games. You're not going to need this for a card game because you don't really need interpolation. Ultimately, you can use this extension as long as the RPC data transfer rates are going to satisfy your game's requirements because that's what this extension is built on top of. And you may not want to use this for a real-time strategy, an RTS type of game, because that's going to be synchronizing state of potentially hundreds of units from multiple players in the game, and that might be a little overwhelming for this type of algorithm. For something like that, consider a strategy called rollback and prediction. I believe Snowpet Games has a great video series on this, and I'll link that down below. And if you need something that's faster, well, you're probably going to be working with lower level networking APIs where you can build and send the data packets exactly when and how you want. It's hard to say which games are best suited for the client prediction and reconciliation. I don't even think this demo that I'm about to show you is the best suited game style for it even, but it's all about what your requirements are and will this lag compensation work for the movements or motion that you wish to smooth out for your game. The extension is opinionated in some of its implementation and may not cover every use case that you might be looking for, but it is in active development and the maintainer is excited about building out the feature set. And of course, there are some limitations and caveats with this, so I'll touch on those as we go and again at the end of the video. So for this video, if you're interested in following along, head over to GitHub and grab or clone the Godot Steam Multiplayer extension repository. This is where we added Steam support using the GD extension version of the multiplayer implementation. So we're not going to look at anything Steam today. I just think this is a good starting point if you want to follow along. So go ahead and clone that project, as that's going to be our starting point. Once you have it open, we need to add Netfox to it. So head over to the asset lib tab and type in Netfox. And for this one, we'll just need the regular Netfox over here. So click on it, download, and it will install. Hit install. And you'll notice there's a few errors that pop up once it's installed. So what we need to do is go to the project menu, project settings, and we just need to enable it. So hit the plugins tab and just check enable for both. Close that. And as a good measure, restart the project right now, because I believe that it needs a good restart before some of the functionality will work. All right, so now that we have our project back open, we can check under the add-ons folder, and you can see there's Netfox and the internals that need to make the plugin work. And we're not going to really use the game scene today. So what we want to do is head over to the scenes folder and open up the multiplayer scene, the multiplayer player scene, I should say. And we can get started there. Let's go over to the scripts tab and close this other script. We also want to open up the multiplayer input script. So under scripts, multiplayer, let's open up the input. And we have the controller open. So those are pretty much the two main files that we'll need for this demonstration. So under the multiplayer input file, we need to make a few changes. In our physics process, you can see how we gather the input direction. We're still going to use this input direction to synchronize the client's inputs between the server and other clients. However, we're going to do it a little differently. Under the ready function, we're going to use the network time library. And this comes with Netfox. And we're going to set a signal to before tick loop. Let's connect that signal to a function called gather. And then of course we need to actually create that function. So let's stub it out really quick. And if we check with the documentation for Netfox under the responsive player movement, there's a basic tutorial on how to get up and running. And this is really just covering the steps that are outlined here. So if you'd like to try this on your own, you can always check out the docs here. Behind the scenes, Netfox has a network tick loop that will remain consistent regardless of, FPS and that sort of thing, or whatever lag you may have. And this is going to be synchronized between the client and server. So when you see us using the network time functionality, we're basically getting the class or the node aware of that network tick loop that is running. So instead of using physics process, in this case, we're going to use gather to put the input direction in line with that network tick loop. So let's grab that and paste it in the gather function. We can actually remove process physics. And if this is not an authority, which is the client in this case, so if it is the client, we're good. But if it's not the client, we just want to kick them out. And since this is our multiplayer input, we have defined it as client authority. And while we're in here, I want to change how we're doing the jump. So up here, let's create a new variable called input jump. And while I'm up here, I'm also going to set the input direction. Let's grab that input jump variable. Down here, instead of is action just pressed, let's get the strength. I found this was an easier way to implement the functionality instead of an RPC in this case, or you can just leave it if you'd prefer to use the RPC version. So since I'm not using it anymore, we can just delete this. And we also can delete the player reference, which I never really liked to begin with. So I'm glad to see that go. And we're also going to remove this username stuff I added earlier because it was basically a hack just at the end of that other demo video. So we can just remove that from there. And underneath the input synchronizer, we can remove username and input direction because we're no longer going to use it. And while we're at it, let's just go ahead and delete the input synchronizer because we aren't going to use that one anymore. Great. So now we've established our inputs to be gathered and collected with this before tick loop function attached to the network time, which is provided by the Netfox extension. So now our input direction will be collected in a consistent manner and processed with that network tick loop. So now that we've changed how we establish our player movement, we need to make those adjustments back over onto the controller. But first, let's create a new node called input. Just name that input. And since we removed the input synchronizer, we need to attach the multiplayer input script to that instead. So let's find the input, multiplayer input. So anywhere you see input synchronizer, we don't need to use that anymore. We need to establish a new variable that represents that player input. So let's do export var input, player input. And of course, I need to go back to this class and rename it player input. Oh, and since we removed the player synchronizer, we can just call this a node. So I'm happy to see that cleaned up. And there we go. So since we removed the input synchronizer, let's go through here and remove any references to it. So now we're going to call input set multiplayer authority instead. And now that we've established this export, we need to connect it. So select multiplayer peer, and let's just drag that to the input field there. And down here, there's another reference to input synchronizer. So let's just remove those. Oh, well, this is username and I'm not going to use that anymore. So we can just delete that. And I think there's another username reference down here. Let's just clean that up while we're at it and see, is there two more at the top? Okay. Okay, so to enable this player to have the lag compensation, we need to add a rollback synchronizer to it. So let's select it and hit add child node and type in rollback. And there at the bottom, you can see it. So let's hit create. And I'm just going to drag it up to the top to organize it. So the rollback synchronizer under root, we need to assign it to the multiplayer player object or your player root object. So the rollback synchronizer is what we use to enable lag compensation. So it's going to collect two different things: state properties, which are the properties that we want lag compensated, and input properties represents what the actions the player has done. So input direction and input jump that we just refactored over underneath the multiplayer input script accordingly. So what's going to happen is the rollback synchronizer will collect those inputs and simulate the states on the server, and it will reconcile those states with the clients so that the player will be in the correct position. So what we need to do is track input direction. So let's just add another element, and we're going to type input : input direction. So it's input and then input direction and then input jump : input jump. We use that colon notation because that's how you get node paths, and that should do it. And again, the rollback synchronizer will use these inputs to simulate what's actually happening and get the true states of where the player should be. And it will synchronize those values back to the clients to make sure that they are on the same page so that those movements are built off correct authoritative states. And the rollback aware properties that we want to add here are the ones that we want to have compensated for lag. So in this case, we want to compensate for global transform. You could probably use position here. I'm actually just following the docs, and I have experimented with position and I believe it works fine. But for this demo, I'm just going to use global transform, but feel free to use position. And we're also going to track velocity because it was another property that we needed to correctly compensate for the lag. So now that we have our rollback synchronizer, we need to make our script, our player's controller, rollback aware. So what does that mean? Well, we need to implement something called a rollback tick. So let's go down above the apply movement from input, and we're going to create a new function called rollback tick. And you can read more about it underneath the documents under the rollback synchronizer section or even the responsive player movement. They give you a pretty good idea of what these different nodes do. I'm just going to gloss over them today, but if you'd like to learn more, feel free to dive in. Here's this section under rollback aware scripts where they show you how to use the rollback function. So instead of calling apply movement from input from our process physics down here, I want to call it from the rollback tick. So by calling to the player movement scripts from the rollback tick, you're making it rollback aware, which means it will be in line with the network loop ticks to make sure that everything works properly with this lag compensation functionality. So we no longer need to call it from our physics process, we can remove it. We also are going to remove the use of is on floor and this set alive functionality here. So we can also remove that, and I'll come back to that in a second. And I want to put this animations in the process function and not physics process. So we don't really need a physics process anymore. So remove that and let's just change this to process. And now our animations will be applied in the process function. And since we just removed a call to our setAlive function, I'm going to go ahead and remove it here while I'm down there looking at it. So now we need to make a few changes to our apply movement from input. The first thing I want to point out is that we're using this check for isOnFloor. If we check with the rollback caveats underneath their documentation, there is an issue with checking isOnFloor that can be resolved with this workaround that is documented here. You basically have to run a move and slide with a 0 velocity. Just a quick workaround to make this work. So we're going to implement this workaround really quick so that this is properly implemented. So right here, let's create a new function. Let's name this force update isOnFloor. Let's grab a reference to our velocity, set the velocity to 0. Let's run a move and slide. Because that isOnFloor doesn't work until move and slide is run, we're basically doing a quick hack with a 0 velocity to get that move and slide update to be registered so that the isOnFloor call will work properly. All right, so let's grab this function. And right before we call isOnFloor, let's just make a call to it. So this isOnFloor conditional just checks whether or not we need to add gravity. But if we are on the floor, we can see if we have a jump input. Since we just updated our jump input, we need to handle that. So let's do a conditional that checks to see if we have an input jump. And we're going to check to see if it's greater than 0, because if it's 0, well, we're not jumping. So let's handle the jump, which is very close to what we're doing here. So I'm going to grab this velocity y, and I'm actually going to delete this part. And let's apply the jump velocity. And then we're going to also multiply it by the input jump strength, which will most likely just be 1 in this case. So our jump logic has been updated. So down here where we get the input direction, it's pretty much the same as before. I want to establish a local variable called direction instead of synchronizing this direction at the top. So let's remove this really quick. And if you also remember under the player synchronizer, we need to remove the direction from there because we're not going to synchronize that anymore. And we're also going to remove the username. And I'm not going to use isOnFloor anymore. And I'm not going to use doJump anymore because we've completely changed our jump logic. And while we're in here, we don't actually need to synchronize position anymore because we're going to be using this rollback synchronizer for that. But one thing that was a bit of an oversight is this player ID. We don't need to continuously replicate that. So make sure you set it to never. That was a bit of an oversight on my part. So if you leave that to always, this is constantly spammed, this setter. And that's kind of a bad thing to have happen during your game, is just to have this unnecessarily spamming the setting authority. So if you're working with my demo project, just in any capacity, whether it's for this demo or previous demo, just go under this player ID synchronizer and move this to never. It'll establish the player ID on spawn, which is good enough. All right, so now that we removed doJump and isFloor, we can go ahead and actually remove those variables as well. And let's establish a local variable underneath our apply animations. So var direction equals input direction. Okay, so because this is synchronized, it will correctly handle the animation direction on the clients. And we're no longer using isOnFloor, so we can just use the real isOnFloor call, if I can spell it correctly. I'm not exactly sure why this wasn't working before, but it seems with this refactor, the typical check to isOnFloor works as expected. As a workaround before, I had created that isOnFloor variable, which we no longer need now. So if we scroll down, we're also getting errors because we don't have a direction. So let's just create a local direction. And again, this is for our apply movement. And I believe that was all the fixes for those variables. And if we check back with the documentation, we can assign velocity by using the input. So in our case, we are just using the input direction. So direction times speed, which is exactly what they're doing here. They're also multiplying the velocity by a physics factor. This just makes sure the rollback aware is in line with the underlying network tick loop that is established by Netfox. So we want to be able to simulate that correctly. So let's go ahead and establish that back in our code. Scroll down here and we're going to do velocity multiplied by network time, which again is a Netfox API. And then we'll just do physics factor. And that should give us the correct velocity based on this tick loop functionality. And another thing they want you to do, if we check under the caveats again, there are some issues where if you don't want to lose your original velocity, you can divide by the same property after the move and slide has been established. This is a bit of workaround. I felt that this was needed in our case, so I'm also going to add that to our game. So if I do velocity, and let's divide it by equals, and we can just grab that network time physics factor, and that should smooth out the movement as expected. And one more thing we need to do before we're ready for a test is let's scroll back up to the top, and I want to grab a reference to this rollback synchronizer. So under this on ready, let's get a reference to rollback synchronizer. And then down under the ready function, which is after we've established our authority. Remember, our authority is handled in the setter before the player is actually added to the scene. So here we want to process settings. And if we return to the responsive player movement docs and we look for the rollback synchronizer, they want you to do this process settings after we've established the authority. So since we know we've already established the authority, I'm not doing it in the ready function, but this is a good place to run the process settings as it's where we can establish the ownership correctly within the Netfox context. So if we run both instances, let's hit new game. You can see I'm able to jump around, and let's join as client, and he drops in. And you can see all the animations are working correctly. You can see him jumping, moving left, moving right, etc. And let's check on the other client as well, the host, I should say in this case. So both animations are working. Great. So this is basically the beginning of having lag compensation. You could probably stop here and the game would have lag compensation. But if you noticed, it was a little jittery, not jittery, but it wasn't very smooth. So what we can do to smooth it out is over under our multiplayer node, let's add another child called tick interpolator. And I'm just going to move this right underneath rollback synchronizer. For the root, we're just going to assign it to the multiplayer player root. So for the properties in the tick interpolator, you want to add the ones that you want to be smoothed out or interpolated so that you don't see that rigid movement. So back under our rollback synchronizer, you can see we're synchronizing this global transform here. Well, we also want to grab that and paste it into the tick interpolator. I didn't need to put the velocity here and it worked just great. But if you do notice some issues, you can probably add that there to clean up any jittery movements that you might see. So let's go ahead and run that again. Post new game. And as you can see, it's much smoother. I mean, I noticed it. I don't know if you guys can notice it with this recording, but if I join as client and we drop in, he's much smoother. He's moving around very great, very smooth and quickly. So these two nodes, this rollback synchronizer and tick interpolator, work really well together. So rollback synchronizer allows you to compensate for lag based on the user inputs given a few properties that you want to have compensated for. So you don't need to put all the properties here, just the ones that you want to be compensated for lag. And then of course your inputs are the things that drive these properties or change these properties states. And then the tick interpolator is kind of icing on the cake. It takes whatever properties you want compensated for lag and then smooths them out so they look great in your game. So like I said before, you could probably stop here if you want. That's basically what's needed for lag compensation. I mean, this is great. It wasn't a whole lot of work. I mean, I probably spent more time removing other code than I actually did implementing this. And if you'd like me to do a demo from scratch, maybe using this game or a different implementation or a different game, let me know. And I can work on that as well. I just thought it was a good idea to continue on using our existing projects to see how easy it would be to switch from using a typical implementation provided by default from Godot over to a lag compensation model provided by Netfox. But if you're going to stick around, which I think you should because we need to update our respawn logic a little bit because we made some changes to it, let's take a look at the kill zone script. If you remember when you hit a kill zone script from the previous video, I have this check here that makes sure that we're on the server, and if our body is alive, then we go ahead and mark the body dead. One other thing we did was lower the time scale to half. Because this runs on the server, that really messes up everything if you're the host. So I don't want to do this anymore. I don't think it's necessary with this progression of the game. Now, this isn't a single player game anymore, so it's not really necessary to do this. So I'm just going to go ahead and remove that. And the body alive, if you remember from that previous video, was to get around a bug with the collision detection of the body being disabled and re-enabled and not re-triggering this collision. You can rewatch that first Brackeys video. I cover all that there. So what happens is we make a call to mark dead on our player object. So we can go ahead and close this. I just wanted to show you that. And that is called right here. And one adjustment I want to make is let's just move this disabling of the collision shape above the alive call. I just felt like this worked better. And what happens is a respawn timer is kicked off, which is set over here about a little over half a second. And then it will call down to this respawn function here. And again, I also want to change the order of this. Let's just make this happen right away. And let's add another variable called respawning. We're going to set that to true. And we're actually going to move this position. So I'm going to comment that out for now. And let's just establish this variable at the top. And let's set it to false by default. And since down here at the bottom, our respawn function sets responding to true, we need to actually use that somewhere. So if we scroll back up to the rollback tick function, I'm going to close this animation so I can see it better. Let's wrap this call with a check to make sure that we're not responding. So if we're not responding, meaning we're under normal operations, we're just jumping around and playing the game, we're going to apply our movement code. However, if we are responding, let's take that position that we commented out earlier and just kind of remove that. And let's just paste it right here. And before I forget, let's set the responding back to false so we don't accidentally run in here again. And since we moved across the screen, right, so we died somewhere on the map and we're going to reestablish that player back to the beginning of the level. So I don't want to be running all of our physics stuff while I'm doing that. And I also want to set the velocity in case there is any left over back to 0. And since this is kind of moving the player across the screen, well, that's not really going to work well with this whole rollback scenario. So as a workaround, they've provided a way to inform the underlying tick components or the underlying processing for this tick to ignore this movement. And the way that we do that is we grab a reference to our tick interpolator and we just call teleport or teleport, if I said it correctly. And what that does is it just basically ignores the last position or state that we had made because we just manually changed that. So we're not going to worry about trying to interpolate between those two areas, and we're not going to worry about tracking or rolling back and making sure that those states are reconciled correctly because this is a server authority driven teleportation, which means it was done on purpose. And if you want to read more about that teleport functionality, check out the tick interpolator docs under sudden changes and you can read more about it right here. So now that we've teleported across the screen, I want to set the player back to alive so that we can start playing the game again. And this alive really doesn't do much as far as this controller. This alive again was to prevent that bug where we just keep spamming that collision detection. Again, watch the other video for more details on that. But I want to give the underlying mechanisms for the collision detection a chance to work itself out. Because remember down here, we just set it back to true. We just actually re-enable collision detection. So I want to give it a chance to reestablish itself before we mark this back to true. Otherwise, it'll just keep spamming it over and over under the kill zone scripts, and we don't want it to do that. So I'm going to add a little timeout here to prevent that spamming. Let's just do a half-second timeout. So that should allow enough time between reestablishing the collision detection and setting alive so that we don't end up in this like infinite spam loop of constantly dying. Okay, so let's go ahead and do a test really quick to make sure our respawn functionality is working properly. Let's host new game, join as client. And we'll drop in and looks like things are going well. And if I just fall down here, I should just respawn back. Okay, yeah, this is working perfect. This is working as expected. So let's try to die on the host just to make sure we've got everything working correctly. And we'll just go ahead and slam into our slime and then we die and get respawned. Okay, so our respawn logic has been greatly improved. Like I said before, development is iterative. We will make our improvements as we go. Speaking of the slime, let's go over and open up our slime scene. So what I want to do with him is I want to make sure that his lag is also compensated, but it's going to be from a server authority. So we don't really need to use the rollback synchronizer. We're going to use something called a state synchronizer. And so if you check out the docs, why would you use a multiplayer synchronizer versus a state synchronizer? Well, you would use the Netfox state synchronizer if you want something or some property of a node to be interpolated, like position, or any other visual properties. And he talks to that here in the documentation. So you can use multiplayer synchronizer to synchronize health or maybe damage or something like that, because you don't really need it to be smoothed out or interpolated. But state synchronizer provides us those tools to really make that happen. So what I want to do is let's add a state synchronizer here. There it is. And we're going to just move it up to the top, not under animated sprite, just up to the top here. And we're going to assign the root to slime. And the property that we want to interpolate or smooth out over the network is position. And again, because this isn't an input driven thing or an input driven node, this is a server authoritative node, meaning it's just driven by the server. So the server is just going to tell this like where to go, where this mob or NPC should go. That's where you would want to use state synchronizer, because it's not based on user inputs, it's based on some authority calculation. And in this case, we're updating the position based on direction and speed of calculated by the little animated 2D sprite calculation. So that's all that's going to do here. So we don't need to use a rollback simulator. We can use the state synchronizer. But because we want to use a state synchronizer for this NPC or mob or whatever you want to call it, we need to register them with the network tick loop, the underlying tick loop that is going to calculate and make everything network aware of the properties that need to be synchronized. So underneath the function or the ready function, I can spell today, let's grab a reference to the network time autoloader and on tick, and we're going to establish a connection to that signal to a function called tick. And instead of process, we're going to call tick. And it's going to take delta and then the tick. And that should clear that up. Great. And then all of this will run within that network aware network time loop that will establish and synchronize all the properties correctly and make sure the movement is processed in a consistent manner, regardless of FPS across the network. So this just really establishes that it's going to be synchronized and interpolated correctly. Okay, so we have everything established here. Let's go ahead and run it. And there he is. You can't really tell, but he's moving fine. There's no real issues with it. I think the animation may be hiding some of the rigidness or slight jitters that this is having, but it looks pretty smooth as is. But let's say you had an NPC that wasn't so smooth. Let me actually just double check that the client side looks smooth, because maybe that will notice it more. No, they look pretty good in both scenarios. And you can see now that the slime is correctly synced, by the way. That hasn't been done in my project for a while, so now it is synced. But let's say you had some NPC that you really wanted to smooth out. That's where we want to add that tick interpolator again. So tick interpolator works for both state synchronizer and the rollback synchronizer that we used in the multiplayer controller. So because we're synchronizing position, let's go under the tick interpolator and let's assign it to the slime root. And we'll add another element here and just paste in that position. So now it should be buttery smooth, like it says in the docs. Oh, I made it awesome. I don't know, he looks smoother to me, but either way, that's how you do it. You can smooth out your mobs or NPCs that are authority driven using the state synchronizer and tick interpolator. So this is a great example or a great use case of where you would want to use that. Now, another use case you might think is, well, why don't we synchronize this platform? Isn't it basically doing the same thing? And I would agree with you. However, there are some hangups right now, or maybe something is broken where typically when you use move and slide to move a player, like, back and forth, it will carry over that velocity, or the velocity will be shared by the platform when you land on it. So if I land on this platform, it should hold me and carry me across on it, right? But it's broken right now. And I don't know if it's something in my code or maybe how this is applied, but I have to keep moving the player. It won't actually just sit on it. And that is not the default behavior of platforms. If you look at the move and slide, let me pull it up really quick. If we go look over at the move and slide documentation, and if we read down here, it says when the body touches a moving platform, the platform's velocity is automatically added to the body in motion. So that's currently not happening. So maybe that's an issue or an improvement or an opportunity to improve the current implementation of our state synchronizer. Or maybe it has something to do with the character body interacting. My gut is saying it has something to do with the character body and the rollback synchronizer and how it interacts with this platform class, underlying platform script. So, that's just something to consider if you're going to have a ton of platforms in your game. Do a proof of concept, and regardless of what type of game you're going to do, Netfox will work for many solutions, but it might not work for your game. So just make sure you do a small proof of concept first with some, with a slice or a column of examples, so that you can make sure that it's going to function as you expect before you really just, commit to something. But right now we have a super smooth movement and synchronization between the two clients. And I was hoping to do a test on a server today, so a dedicated server. So let me try to set that up really quick, and we'll see you back in a second. To test on a dedicated server build, let's go under project export, and I'm just going to add a Linux, and this will be Linux dedicated server, and under resources, and we'll just select export as dedicated server and hit export project. And I have a server folder here, and I'm just going to rename it to server to make it easier for me to type. And that's it. Now we have a dedicated server, and let me upload it to my EC2 server that I'm hosting in Oregon. So I'm on the East Coast, and this will be hosted in Washington State. So it's pretty far away. So it'll be a pretty good test to see how smooth these things run. Even though I have pretty good internet, it should give us an idea of what to expect. Just uploading it right now. Okay, so I got a dedicated server running out in Oregon, and let's see if I can update this project to connect to that. So underneath eNet networks, I need to change the localhost to point to the DNS. So now I updated the clients to join to the EC2 instance, which is running over in Oregon, which is across the country from me. So we should have a little bit of lag. So I'm gonna join as client. Okay, there's my first client. He's running around. Seems pretty good to me. Seems pretty smooth. And let me see if I can join a second client. And yeah, I mean, I'm able to move around pretty quick. This is traveling across the whole country, and you can see it's pretty accurate. It's not too jittery. It's actually really smooth. The platform is synchronized fairly well, even using the default multiplayer synchronizer, even with that bug that I talked about a minute ago. Let me try to jump over on the other client, see if I can do it without dying. And yeah, even our slime is moving really nice and smooth there. You can see there's not really any delay with that. So if I jump over and cross him, great. So I think this is a pretty good idea of maybe some real world scenarios. Like you might have a dedicated server deployed somewhere, and your clients are going to connect to that, and you're going to have some lag. I probably only have like 40 milliseconds of lag, to be honest. Like I have a pretty good internet connection, even though this is all the way on the other side of the country from me. I'm on the East Coast, and this is on the West Coast, the server. So I mean, overall, you're going to see some movement artifacts here and there when it corrects it, and there are some ways to fix that which aren't really implemented in this version. That's some improvements that can come down the line. And I'm not going to get into that today, but yeah, I mean, this works pretty well for a basic lag compensation. So if you're interested in getting started, definitely check this out. So I just want to wrap up with a few caveats that I noticed and discovered during the use of this plugin. The maintainer seems to believe that there may be some limitations using this in P2P, as I believe server is hard-coded somewhere. And I think in most P2P setups, this won't be an issue because we usually mark the host as 1 or authority 1. So I think it may work okay. I've actually tested this in a local setup, a dedicated server, and even Steam, and I didn't see any problems. And as you saw from the video, the dedicated server worked great. And I think that is mostly what this is geared towards. But in general, if you notice any issues with that, you're always welcome to, crack into the code yourself, or even, put a pull request out to improve the extension, or maybe create an issue. There's also a companion extension called Norray. You may have seen it when we were originally adding the extension, and that's going to allow you to have a P2P setup through a relay server that the maintainer has put out there for developers to use and test with. So I'm not going to touch on that too much today, but if you're curious to see more about that setup, let me know and I can cover that in a later video. If your game heavily relies on physics interactions, then you may want to avoid this extension. Currently, there's no way to step through and simulate like frame by frame how objects are interacting or physically interacting. So there's no way to roll back and simulate those things to derive the correct state. So we're really limited to just like property interpolation or property reconciliation. So if your game heavily relies on physics simulation, maybe consider using a different approach. Now, there's also some limitations with rigid bodies, but I believe there are some workarounds. But once you get in there and play around with it, you'll have to just make that decision yourself, or maybe talk to the maintainer and join their Discord, and maybe they can hash it out with you. We also saw how platforms were having issues. I touched on that earlier in the video, so just keep that in mind. If your game has a lot of moving platforms and things like that, you may want to get in touch with the maintainer or maybe hash out a solution behind the scenes to see if maybe there is a workaround or a solution, or maybe something I did wrong. And if you find anything, please let us know. The last thing I want to highlight is the display offset. So in like the industry standard, these like fast-paced, multiplayer game lag compensation strategies will render the other clients on your machine 100 milliseconds in the past or some buffer in the past. And it really helps hide that laggy or any kind of interpolation, or it just helps smooth out the movements having that extra buffer. And the clients really don't know that you're rendering a player 100 milliseconds behind where they actually are. And since the server is the authority and actually resimulates everything, then you'll know if those gunshots were accurate or not, because the server will tell you whether or not you were shot in the head or not. But if you are concerned about having that type of feature, currently the display offset does support that, where you can render clients in the past, but currently it also applies to you. So your inputs will also be lagged or buffered in the past. And I think an improvement, which the maintainer agreed when I was talking with him, is that, yeah, it would be a nice improvement to not apply it to you. So you are rendered currently, and then everybody else is rendered that 100 milliseconds buffer into the past. So that's something to look forward to as a future improvement. So like with everything else, make sure that you experiment a little bit and make a few proof of concepts before you commit to using anything. While looking into lag compensation strategies, client prediction and reconciliation really seemed to be a good fit for what I wanted to do. So as I was doing research on trying to write my own, I stumbled upon this Netfox extension and just was like, you know what? I don't want to do this myself. I'm going to use and build off of somebody else's work because I think this is really well done and it has a lot of potential. And even if you didn't want to use all the features, at least use the underlying network synchronizer or network time synchronizer, as a lot of these lag compensation algorithms at their core will have this like in-step network tick algorithm that you need to have so that you can synchronize time through all the peers so that you're correctly simulating things when they should be in the correct order that they should be. So you get the correct results shared throughout all the peers or connected clients in the game. So if anything, use it as a starting point or at least a guide, because I think there's a lot of really good work already done with this project. So if you're interested in seeing or wanting to support this, the growth of this project, please go and like that project and join their Discord, create pull requests to make improvements, create issues if you notice something, or if you want to have a discussion about what things can and cannot do. I know I certainly will. And if you'd like me to do a deeper dive on Netfox or anything else you've seen in this video, please let me know. If you enjoyed this content, please like it, show your support for the Netfox guys and make sure that you give them some support there as well. Make sure you're subscribed. I've got a lot more on the way. Stay connected. Thanks for watching.